Today's topic, plating on plastic. This is a toy car, but even in a modern real car, many parts are plastic. In the toy car, this is directly visible, but also in the car you drive. Plastic is installed in many places, but these parts do not look like plastic. Why do you even want a plastic car? The advantage is a lower weight and no corrosion. The disadvantage is that it doesn't have a high-class appearance. The question arises whether I can achieve that the plastic looks and above all feels like metal. A great way to achieve this is electrical deposition of metals. But if we dip the plastic in a galvanic bath, nothing will happen, because plastic is an insulator, a non-conductor. This function as non-conductor is often favorable. For example, cables are insulated in plastic, so you don't get an electric shock. As an example for the plating on plastic, I used a resin bun. The resin bun is a model for the plastic. The resins are the plasticizer that ensures that the bun is soft and gives the plastic its desired properties. If you want to apply a metal layer, you first need a conductive layer on the plastic. In the first step, the resins are removed in an etching bath. This creates holes which will be important for the adhesion. Both the etching of the plasticizer and the change in the chemical properties of the surface are necessary. Palladium is deposited out of a tin palladium solution. Small metal germs can be accumulated on the plastic part. Since we don't have a continuous layer on the bun, we can't use electricity to add the next layer yet. Therefore, we need an electrolysis process. Nickel is reduced chemically at the palladium germs. Now we have the first conductive layer on our bun. The process is called electrolysis nickel, as it absorbs on its own and is not deposited by electricity as an electrochemical bath. The holes in the plastic are filled and increase the adhesive strength, similar to a push button. Electrodeposition of metals is now possible. The first metal we deposit is copper, which provides the leveling and the gloss. It is also important because it reduces the stress on the component due to thermal expansion. Otherwise, there would be cracks and damages in your resin bun if you take it outside in the winter. After the copper, white nickel is deposited. This layer is harder than the soft copper and can protect against scratches and deformation. For decorative purposes, a chromium layer is applied at the end. In this case, a dark type, SurTec 885. We now have a component that is light in structure but has a different look and feel, a valuable surface for premium applications. Now when a cross-section is created, one can see the different layers on the one side for the real part and on the other side for the resin bun model. These layers are the resin bun, powdered sugar, frosting, sugar sprinkles, a wafer and coffee powder. We can see that the metal layers are entangled to the workpiece by the push button effect. In difference to the resin bun, all our products are gluten and lactose free. We at SurTec haven't only developed dark colors of chrome, but also several other shades. With our brand new SurTec 883 XT, we are the first ones to achieve the very same color that the old hexavalent chromium process provides.